The critical things of animal breeding is measurement is still really important, and that reference population is really important. High quality data is still important. The bit that is critical is animals that are genotyped and phenotyped. So any animal that is measured for a trait and has a genotype becomes part of what we call the reference population. So prior to that, we were just relying on relationships between animals, half from mum, half from dad, a quarter from each grandparent. On average, that's correct, but individual relationships can vary. So we see it in humans. You can be, you see a throwback to a grandparent or something. You go, gosh, they actually look a bit like that grandparent, but not like another one. The relationship you might have between your grandparent might vary from about 13% to 30%. And we see exactly the same thing in sheep. So the way we use genomic information is actually all about the relationships of that animal that you genotype to all, say in merinos, the other 600,000 animals that have got a genotype and a phenotype for that measurement. So it's all relationships. We're not looking at individual genes. And then it comes into genomic selection. And that's really where we get the power, is not just an animal having a genotype, is then using the breeding values produced from that genotype to make a selection earlier in life for traits that would have been too difficult to measure otherwise, or measured much later in life. And that is really where we get the power of genomics.